Ya, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. So for today's lesson, we will look into the intermolecular and intramolecular forces. So for intramolecular forces, we have primary forces, okay, known as primary forces, and the second one is the secondary forces, which is known as intermolecular forces. So what is intra and intermolecular forces? So we look at the meaning of intra and intermolecular forces first. Intra Intramolecular forces are the forces that hold atoms together within a molecule, while intermolecular forces are forces that exist between molecules. So by looking at this example, the atom that hold hydrogen and chlorine cotton is known as the intramolecular forces, intramolecular attraction, while the bond that exists between this chlorine and hydrogen is intermolecular attraction. Okay, look at this figure. It illustrates um, the bond that exists between these two towels. Okay, let's imagine that this is the hydrogen close and chlorine. Okay, so these two towels, we need a thread and needle to sew the towel of one hydrogen to one chlorine. So hydrogen have H, so chlorine is Cl. Then after sewing, lepas kita jahit kain dua ni, we found that it is the presence of the intramolecular attraction between hydrogen and the chlorine. So after sewing, we can see that it has three pairs of towel. Okay, 1, 2, 3 pairs of hydrogen to chlorine. So we use a Velcro tape. Okay, this is a Velcro tape to attach these three pairs to each others. So kita gunakan Velcro tape ni untuk kita lekatkan tiga pasang towel ni antara satu sama lain. So this Velcro tape junction is represent as the intermolecular forces. Okay, and while for this green one is represent for intramolecular forces. Yang colour hijau yang kita jahit tadi adalah intramolecular forces. Okay, for Velcro junction, it will break. Okay, Velcro ni dia akan koyak. Manakala untuk bond yang kita jahit ni, this sewed junction will stay. So means that the attachment made by Velcro is weak compared to the thread and needle. Okay, so we can see that each hydrogen and chlorine, between the hydrogen and chlorine atom, it has dipole-dipole attraction. Okay, so the dipole-dipole attraction between the hydrogen, chlorine and hydrogen here is represented by is types of intermolecular forces. Okay, so for secondary forces, we have hydrogen bond, van der Waals, dipoles, polar covalent bonds, and okay, we have 1, 2, 3. Okay, sorry, we have dipole, van der Waals, and hydrogen bonds. Okay, so dipole is the strongest bond in secondary forces. The second one is hydrogen bond, and the last one is the van der Waals bond. So between the chlorine and hydrogen, it exists of the dipole-dipole attraction. Okay. So between hydrogen and chlorine, this strong atom is the presence of the covalent bond. Okay, and between the chlorine and hydrogen here is the dipole attraction. So for primary forces, it has ionic, covalent, polar covalent bond. Dia macam tu, tiga tu lah. Okay, look at the next slide. Okay, for primary forces, we have covalent bond. We will cover about covalent bond and ionic bond. And secondary forces, we will cover about dipole, van der Waals, and hydrogen bond. So the secondary forces exerts deep effect on many of the physical properties of polymer, like crystallinity, thermal transition, and melt viscosity. Okay, first covalent bond, which is in intramolecular forces, primary forces. This is formed between atoms that have similar electronegativities, so the affinity or desired for electron. So a non-polar covalent bond is formed between same atom or atom with very similar electronegativities. So the difference in electronegativity between bonded atoms is less than 0.5. Okay, by looking at this example, we can see that Cl atom, it share valence electron with each other. Okay, so this type of electron sharing is known as a covalent bond. So it keeps the shared electron close to both atomic nuclei. Okay, so one pair of shared electron makes one carbon bond, a covalent bond. Okay, so this pair electron, okay, one pair of shared electron. So this share electron between this, so it makes one covalent bond. So a molecule is a group of atoms held together by the covalent bond. Alright, so to determine how many covalent bond can be formed between these atoms, so first we have to know the number of valence electron in that atom, which can be counted by using Reddit table. So for example, if we have a carbon element, so kalau carbon element dia ada valent, dia adalah elemen 6, so dia punya valent electron adalah 4. Okay, so we can see that a non-polar covalent bond between Cl atom is formed between the same atom or atom with very similarity electronegativities. Okay, for polar covalent bond is formed when atom of slightly different electronegativities share electron. So hydrogen and chlorine, it share this polar covalent bond. So Cl, we can see that the Cl atom has more electronegativities compared to hydrogen, which is 2.1. So the difference in electronegativity between the bonded atom is lies between 0.5 to 1.9. So pulls the pair of electron toward itself. So it develops a partial negative charge, and as a result, hydrogen gets a partial positive charge. So this is a polar covalent bond. Okay, we'll look at the dipole forces. So dipole forces is a forces in the intermolecular forces, secondary forces. So when the two atoms having different of electronegativity are bonded together, the resulting bond is not absolutely nonpolar, but bears negative and positive charge of the extent proportional to the difference of electronegativity. Such bonds are said to have dipole, so the greater the difference of electronegativity, the greater the intensity of charge and greater the dipole. So dipole bond or dipole forces is the strongest bond in the secondary forces. Okay, so for dipole forces, there are the attraction between the positive end of one polar molecule and the negative end of another polar molecule. So the polar molecules have a partial negative end and a partial positive end. This is the structure for PET. So PET, it has the oxygen here. This oxygen containing functional group make it a polar polymer. So in this structure, polar molecule have a partially negative end and a partially positive end. So the partially positive end of polar molecule is attracted to the partially negative end of another. So in HCl molecule, the more electronegativity Cl atom bears the partial negative charge. Okay, so we can see that it carry a negative charge, which is more electronegativity. Okay, for H hydrogen, it carry a partial positive charge, which is less electronegativity. So partially positive, okay, partially positive hydrogen end of HCl molecule is attracted to the partially negative Cl end of another HCl. Okay, so for dipole forces, bind polymer chain together and increase the mechanical properties. Okay, we'll look at another type of intermolecular forces, which is van der Waals forces. So in any material, all the molecules attract one another since the nucleus of each molecule exerts slight attraction on electron of the other molecule so that the molecule come nearer to one another. However, the repulsion between the electron of different molecules become prominent if they came too close to one another and thus keeps them at a certain distance. So the forces that keep a polymer to each other at certain distance is the forces called as a van der Waals forces. Okay. You can look at the hydrogen bonding. This is a special kind of dipole-dipole attraction that occurs specifically between a hydrogen atom bonded to either an oxygen, nitrogen, or fluorine atom. So the partially positive end of hydrogen is attracted to the partially negative end of the hydrogen, nitrogen, or fluorine of another molecule. So hydrogen bonding is a relatively strong force of attraction between molecules and considerable energy is required to break hydrogen bond. This is an example of hydrogen bond for OH structure. So the molecule with either NH or OH will form strong secondary forces. So this phenomenon is responsible for the relatively high boiling point of water. So that's why the fact that its ice is less than its liquid form because of the hydrogen bonding. Okay, that's all.